Today we're going to talk about the equations of circles. But before we begin, I want to review some old school circle facts, some things that we learned a long time ago in middle school that we might have forgotten, because they're going to come up a lot when we talk about circles and the equations of them. So some of you might remember learning about CARD. CARD was just an acronym that helped us remember four important elements of circles, and that if you know any one of them, you should know all of them. So when we talk about CARD, I'm going to start with the smallest thing here with the R. The R stands for the radius. And we all know that the radius is the distance from the center of the circle to any point on the circle. I'm going to put a little r here, and that's your radius right there. The d is the diameter. And the diameter is the longest chord you can draw in a circle that starts and ends on the circle and goes through the center of the circle, which happens to be, oh, here, I'll put a d there. That's the diameter. The C is the line that actually goes around the entire circle, that actually makes the circle. In this picture, the orange line is this circumference. That actually has a length, and that is the circumference. I'll put a big C over there, the circumference. And finally, the A is all of the space inside the circle, right? The area of any figure is all the space inside that figure. So if I were just to kind of tap in here, there you go. The entire green area would be the area of the circle, right? And that is big A. And there you have it. So CARD, circumference, area, radius, diameter. And yes, all of these do have formulas. Let's imagine that the only thing given to us in a circle is the radius, which I'll write as lowercase r, the length of the radius. Well, if the radius is the distance from the center of the circle to any point on the circle, the diameter is really just 2 radii. So the formula for the diameter would be 2r, right? And the circumference and the area are kind of tricky. They're the ones that involve the famous, right, pi, right? So if we're going to find the circumference, it's as simple as taking our diameter and multiplying it with pi. They sometimes say d pi, but we already know that the d is equal to 2r. So sometimes you see the circumference written as 2 pi r, because the 2 times the r is the same as the d. Now, the area is also a pretty famous one. It's pi times the radius squared, or pi r squared. And both of these formulas are formulas that are given to you on the math reference sheet. Well, so here I'm just going to do one quick example. Let's pretend we were given a radius of say, 7. Then we should very quickly be able to formulate that the diameter is 2 times 7, which is 14. Since our diameter is 14, we would know that our circumference is our diameter, which is 14 times pi. I'm just going to leave it like that, 14 pi. And that our area is our pi r squared. So I'm going to square my radius and get 49, and then multiply that by pi. That's kind of old school, middle school math. Given the radius, the diameter, find the area and the circumference. And of course, everything we do forwards, we should be able to do backwards. So very quickly, just to run a couple through a few examples. Here's a picture of a circle where they're giving us the radius of 5. Well, I know the diameter is twice the radius, so it has to be 10. Whatever the diameter is, that will be equal to the circumference times pi, that irrational number. And if the area is pi r squared, it's going to be our radius squared pi. So here was given the radius, I was able to find everything. Well, here's a problem where they're giving us, obviously, the diameter. Well, if my diameter is 18, I know that my radius is going to be 1/2 of the diameter, which would be 9. I know my circumference is my diameter times pi, 18 pi, and my area is going to be my radius squared, which is 81, times pi. Well, here's an example where they're giving us the circumference in terms of pi, with a pi there. Well, that makes this pretty simple because all I got to do is take away that pi and I get my diameter. Take half of my diameter, that gives me the radius. And then square my radius times pi will give me 100 pi. So given any one of these elements, we should be able to pretty easily find the rest. And here, the final example, they're giving us the area, which is 36 pi. Well, I know if I take off the pi and find the square root of 36, I'll know my radius. If I double my radius, I'll have my diameter. And if I take my diameter and multiply pi, I got my circumference. So that's all really review, but I just wanted you to kind of get that back in your heads as we go forth with this next new topic, which are the equations of circles. So equations of circles come in a couple different forms. The first form we are going to learn about is called the center radius form. And forms are usually named after what you see, what you can extract from them just by looking at the formula. And we're going to be looking first at the circle radius form when the center of the circle is 0, 0, the origin, because they're always going to start the same. Like this picture on the right, you can see the center of the circle is 0, 0. Well, all circle equations that have 0, 0 as the center of the circle all begin with x squared plus y squared. So as soon as you see x squared plus y squared equals something, you already know that the center of the circle will be 0, 0. Now, here's where the number comes in. This r is going to be an actual number in an actual equation. So it's going to be x squared plus y squared. Then we know the center is 0, 0, but it's going to be equal to our radius squared. So if we look at an example down here and we see x squared plus y squared equals 9, and you remember this form up here that says x squared plus y squared is equal to your radius squared, you then could take this number that it's equal to and set it equal to your radius squared. Well, my radius squared is equal to 9. Well, in order to solve for r, to find what our radius is, we're just going to take square root, and we find that our r is 3. Actually, positive and negative 3. So you could see that if we go to 0, 0, and we say on our x, our radius is positive and negative 3, we're going to go positive 3, we're going to go negative 3. And then for our y, we're also going to go positive 3 and negative 3. And then we can just take our compass out and very simply draw our circle. So this circle right here with 0, 0 as its center and a radius 3 has this equation. x squared plus y squared equals 9. It is that simple. So let's take a look at a couple examples. Here in this first one, they're not really giving me an equation, but they are telling me that on the accompanying grid, graph the circle whose center is 0, 0. Okay, I'm going to put 0, 0, put a point at 0, 0, and has a radius of 5. Well, if it has a radius of 5, that means I can go in every direction 5 and put a point, which would be on this circle, right? So from 0, 0, I'm going to go up 1, 2, 3, 4, 5. I'm going to go to the right 1, 2, 3, 4, 5. I'm going to go down 1, 2, 3, 4, 5. To the left 1, 2, 3, 4, 5. And then I can just put my compass on the point and draw a circle. I'm just going to use my circle because everything's going a little slow right here. So I'm going to just put my pointer right down on the center and just open up that until it touches the points. And there you have it. That is a circle with 0, 0 as the center and a radius of 5. Now, if I wanted to write the equation for this circle, I'm going to come down here. Well, it has a center of 0, 0 and a radius of 5. Well, we just learned that all circles that have a center of 0, 0 all start exactly the same way. X squared plus y squared. And they're always going to be equal to the radius squared. But we know that the radius here is 5. So I'm going to substitute that in. X squared plus y squared is equal to 5 squared. And then we get our equation of the circle, which is x squared plus y squared is equal to 25. Now that's important because it's going to help us answer this first question. Determine algebraically if the point 5, negative 2 lies on this circle. Well, it's really simple to test if a point lies, meaning on the circumference, on the line of the circle, because all you need to do is substitute the x and the y of a point into an equation, and then if it's equal, or a true statement, then that means that point is on the circle. So my x is 5, so I'm going to substitute 5 squared plus my y is negative 2 squared, and I'm really testing, is it equal to 25? Well, I'm going to get 25 plus 4 is equal to 25, and obviously 29 is not equal to 25. So that means that this point is not on circle. And of course, we can go graphically and take a look that 5, negative 2 is right there. And yeah, it is not on that. So we can also see it graphically that that's not on the circle. Okay, so in this next example, they are giving us the actual equation. Whenever I have an equation, I like to remember that in order to graph a circle, I just need two things always: the center and the radius. If I know those things, I can put the center on the graph, I could open up my compass to the radius and just draw the circle. So here, I look at this x squared plus y squared, and as soon as I see, sometimes I do that, sometimes I put a C here, and that just means the center of my circle, but you can put whatever you want there to represent that. And I see x squared plus y squared, I'm going to put 0, 0. And I'm going to say my radius is equal to the square root of whatever this is equal to, because it's equal to r squared. So I'm going to say the square root of 9, which is equal to 3. So my radius is equal to 3. My center is 0, 0. So I'm going to go, there's my center. I'm going to go up 3, down 3, left 3, right 3, and then I'm just going to draw my circle. And there you have it. That is the equation x squared plus y squared equals 9. Now, here is the first time where that card thing might come in handy, because you might remember that the formula for the area of a circle is equal to pi r squared. But you might also remember that the equations of the circle are equal to the r squared without the pi. So quite simply, if they were asking what is the area of a garden to the nearest square unit, you can start by saying, if you have the equation, that the area in terms of pi will be equal to whatever this number is, because that's your r squared, 9 times pi. However, they didn't want it in terms of pi. They want it to the nearest square unit. So we are going to go to our calculators now. And let me bring this back here. All right, bring this up. And I'm just going to put into the calculator, clear this out, 9 second pi, enter. And set to the nearest square unit, which means the nearest whole number, which would be equal to 28 square units. And it's as simple as that. All right, let's just do one more quick example, and then we'll move on to how do we write the equations when the center is not this 0, 0. So here we have Marty uses the equation x squared plus y squared to represent the shape of a fish pond. Graph it. Well, like I said, I need to know the center of the circle first. So it's x squared plus y squared. That means the center is going to be 0, 0, the origin always. And my radius will be equal to the square root of what the equation is equal to, the square root of 16, which is 4. So I'm going to go to 0, 0. There's the center of my circle, and then go up 4, down 4, left 4, right 4, and draw the circle. And there you have it, simple as that. What is the area? Well, we just saw that we know that the area will always be equal to what the equation is equal to, which is 16, because that's your r squared times pi. And here again says to the nearest square unit. So quite simply, we could put 16 pi into the calculator, hit enter, and it's going to be equal to 50 square units. All right, there you have it. Okay, pretty simple when the center of the circle is 0, 0. But let's take a look at an example where it's not. Okay, so it changes a little bit, but not that much. So here is the form. It's really the same form, the center radius form, but it changes only in that the center is not 0, 0. Now, you might notice here when they talk about the center of the circle, we've had this occasion several times, where we don't use x and y. And the reason why we don't use x and y is because x and y are already in the form. So then they do the backup plan where they're going to call, the x of your center h and the y of your center k. And it's still equal to radius squared. That doesn't change. But you might also notice in the form that it's x minus h parentheses squared and y minus k in parentheses squared. So another way to also think about this form is that when you look at the equation, the value for x of the center of your circle will be the opposite of what you see in that parentheses, because it's the opposite of your h. Negative h means the opposite sign, and negative k means the opposite sign of your y. So an example would be if we just jump down here to the bottom here, forget about the process, just look at this right here. This is the equation for this circle right here. And you could see that the center of this circle is positive 2, negative 1, right? Positive 2, negative 1. That's the center of this circle. But look at the equation, and you're going to notice inside the parentheses that has the x, you see a negative 2. The center x will be the opposite of what you see in the equation. So if you see a negative 2 here, well, a negative 2 is a positive 2. So, and if you look inside the parentheses of your y, you see a positive 1. The opposite of positive 1 is negative 1. So 2, negative 1 is the center, and the radius is still going to be equal to the square root, in this case of 9, which is 3. So now, instead of going to the center of the circle, we go to 2, negative 1, and we put the center. And then from the center, we count 3 in each direction and draw our circle. Let's take a look at 2 examples, and then we'll be done with this lesson. So number 7. In the graph the equation x minus 2 plus y plus 2, right? Both squared, is equal to 16. Well, remember, I'm going to have the same exact process as before. If I know the center and I know the radius, I could draw that circle. So the center of this circle, I'm going to look inside the x and see a negative 2. So the opposite, the negative of a negative 2, is positive 2. And then inside the y, I see a positive 2, which means it's going to be a negative 2. So that's the center of my circle, and my radius will be equal to the square root of 16, which is 4. So now I'm going to go to positive 2, negative 2. There's the center of my circle. And from there, I'm going to go up 4, 1, 2, 3, 4. Down 4, 1, 2, 3, 4. To the left 4. And to the right 4. Remember, you can count up, down, left, and right. That's why we go up, down, left, and right. And then you put your compass on the center of the circle and draw your circle. Now, the question about what is the area is not going to change, because the area of a circle has nothing to do with the center. It has everything to do with the radius. So we're going to do this problem exactly the way we've done the rest. What is the area of that circle? Well, the area is going to be equal to my radius squared times pi. Well, I know that the equation is always equal to my radius squared, so it's going to be equal to 16 pi, and we've already put that in the calculator before and calculated that, so I'm just going to skip that. And finally, I'll do one final equation, graphing of the circle here. X plus 2 squared, y minus 1 squared equals 9. I'm going to find the center of the circle by doing the opposite of what's inside my x. For my x, positive 2, so my x value is going to be negative 2. I see a y minus 1, so my y value is going to be a positive 1. My radius will be equal to the square root of whatever it's equal to, square root of 9, which is 3. So I'm going to find the center of my circle, which is negative 2, positive 1. And then from there, up 3, down 3, left 3, right 3. Go to my circle, put the pointer at the center, open up to the radius. And there you have it. So graphing circles is pretty simple. However, just make sure that you're able to work forwards and backwards. Let me see if I have any of those. Let's just look at these two really quick. An equation of the circle whose center is -3, 1, and a radius of 8. Well, this is good practice here, so I wanted to take a second, see if you can write that equation before you even look at the answers. Okay, so let's start with opening up a parentheses when 0, 0 is not the center, and I'm going to put my x here. I see that the x value here is -3, so I'm going to do the opposite, which is +3. It's as simple as that. Squared. Plus, open up a parentheses here and go to my y. I see that my y value here is +1. So I'm going to do the opposite, which is -1 squared. And it's going to be equal to my radius, which they're giving me as 8 squared. So my final answer will be x plus 3 squared plus y minus 1 squared is equal to 64, which we could see is choice D. And let's do the same for 16. Here's my x. Here's my y value of the center. I'm going to open up and do the x first. The opposite of +2 is -2 squared. I'm going to do my y. The opposite of -4 is +4 squared is equal to my radius squared. So my final answer, quite simply, is right here. Is equal to 6 squared, which is 36. So it's right here, choice C. And there you have it. I hope you found this video useful. And if you did, please subscribe to the YouTube channel. See you soon.